today's lesson, we are going to be looking at volume and surface area, or basically 3D measurement. So just as a little bit of a warm-up, this was kind of a Twitter thread that was going around in the summer. So a person ordered a 9-inch pizza, and after a while the waiter brought out two 5-inch pizzas and said the 9-inch pizza was not available, and that he was giving them two 5-inch pizzas instead, and that they were getting 1 inch more for free. So did the waiter give this customer a better deal? On the surface, it might appear like that. Well, two 5-inch pizzas, that's 10 inches right there, which is 1 more inch than 9. So on the surface, it looks like a better deal. But if you actually go into it, is it actually a better deal? What might you look at instead? Right? Remember, we're dealing with pizzas. We measure it, so we're talking about 9 inches in diameter. We're talking about two 5-inch pizzas. So if we're just looking at length, then yes, we have an extra length of pizza. But do we have more pizza? What might we be looking at? Right? If you said area equals pi r squared, you would be right. Check the areas of the two different scenarios. What's the area of one 9-inch pizza? And what's the area of one 5-inch pizza? Or of two 5-inch pizzas? Are they the same? Do you get more with the two 5-inch pizzas? Or do you get less? Well, this person went through and did the math. That's why they called the owner over. So they calculated that a 9-inch pizza had an area of 63.62 square inches, whereas two 5-inch circle pizzas worked out to 39.26. So their argument was, well, even if you give me 3 of those pizzas, I'm still going to lose out. So how can you say that you're actually giving me free pizza? So in the end, this person apparently got 4 pizzas for free. Well, not for free, but 4 pizzas instead of the one 9-inch pizza. So just by doing some math, right, to disprove another person or to disprove the scenario, right? So kind of a unique situation, but this might be something that kind of commonly comes into play, right? Because on the surface, it does look like it's a better deal, but when you actually delve into it a little bit further and use some of the area formulas, you find out that it's not actually a better deal. So some of this stuff does kind of have an applicable or a real world application, because who doesn't want more pizza? So we're looking at surface area and volume though, which is looking at 2-dimension or 3-dimensional figures. Same kind of idea. We're going to be focusing on using our formula sheet, the formulas that we have, and we're just going to work through just some practice questions just to make sure that we're comfortable plugging in the information into our formula. So the volume of a cylinder, volume equals pi r squared times height, and that's it. So pi r squared times height. Again, pi, we can write 3.14 as well. That's an acceptable, in our case, that's okay to use instead of the pi button if you don't have it, or if you prefer just typing in 3.14. We're going to multiply it by the radius. Remember, the radius is half the diameter, or from the center out. So in this case, our radius is 4. So pi times 4 squared times the height, which is 12. So here we have to do BEDMAS. If you have a scientific calculator and you enter everything as you see it, you don't have to worry too much about that. If you're doing it on a phone or something else where it doesn't show everything and you have to do it step by step, make sure you are using BEDMAS, so the brackets or the exponents first, so the 4 squared, and then do all your multiplication. So I used 3.14 instead of the pi button. I got 602.88. If you use the pi button, you would have gotten slightly different, probably slightly a bit more. And we do have a checklist that we can go through. So did we use the correct formula? Yes, we got it right from our formula sheet. Did we use the correct values? Yes, we found the radius and we plugged that in. The correct units. The correct units in this case, we are dealing with centimeters, but because it's volume, it's centimeters cubed. So we do have the correct units, and we can assume that it is the correct answer. We did our calculations correct. We followed order of operations. Looking at the next one, a pyramid. So our formula sheet says a square base pyramid. This is not a square base because we see our two dimensions are not the same. So we can still use the same formula, volume of the area of the base times the height divided by 3. So in this case, the area of the base is going to be length times width. And we're going to multiply that by our height of our pyramid, and we're going to divide by 3. So 14 times 9 times 20. We have our length, our width, and our height, all divided by 3. We get 840 yards cubed. And we can go through our checklist. We do have the correct formula, values, units, and answer. Looking at the rectangular prism, this is probably the easiest one. Volume equals length times width times height. In this case, it doesn't really matter which value goes where, because depending on how you rotate or orientate this box or this prism, you could argue that either of these measurements is considered the length, the width, or the height. So it doesn't really matter which ones you choose, and when you look at the formula, you're multiplying, and order doesn't matter when multiplying. So I can put these in a different order and still get the same thing. So 3 times 10 times 8 is 240 millimeters cubed. Looking at a cone, again going to our formula sheet, volume equals pi r squared h divided by 3. So 3.14 times our radius. Again, our radius in this case is half of the diameter. So half of 7, our radius is 3.5. So 3.5 squared times our height, which is 13. 3.14 times 3.5 squared times 13. Forgot to divide, and we still have to divide by 3. 166.68 inches cubed. Again, whether you use the pi button or pi, it may be off slightly. Next, we're going to look at the surface area. Now, the surface area is still for three-dimensional objects. Imagine if we took, or every three-dimensional object we looked at was kind of like a box, and we had to unpack it. Like it's a cardboard container, and we're folding it flat so that we can put it in the recycling. By folding it flat and calculating the area that that now two-dimensional object takes, that's what our surface area is. Or you can think of it as the area of every face or surface. So we go to our formula sheet. The surface area for our cylinder is 2 pi r squared. So basically those are the two circles, the base and the top. And then we're going to add in 2 times pi times r times h, which represents the lateral surface. So that's kind of the siding around it. So we just need our radius and our height. So 2 times pi, or 3.14 times our radius, which is again half the distance of our diameter, which is 5. So 2 times pi times 5 squared, plus 2 times pi times 5 times the height, which is 17. I would recommend solving this in 2 parts. If you're not too comfortable with your calculator. So 157 plus 2 times pi times 5 times 17. $553.8. Just check the first one. It works out. Just sometimes odd to see a nice whole number when you're dealing with pi. I again use 3.14. So 157 plus 533.8. We get 690.8 inches squared. Because we're back to dealing with area, it is area squared, or our units squared. Looking at a rectangular prism, so looking at our formula, area equals 2 times the width times the height, plus the length times the width, plus the length times the height. So essentially we're saying for our rectangular prism that we have 3 pairs or 3 different shaped faces, and we have a pair of each. So we have 3 pairs of different sides. So this side and the side directly across from it, this side and the side directly across from it, this side and the side directly across from it. Again, does it really matter what our length, our width, and our height is? No, because depending on how we rotate or orientate this box, we could argue that either of these measurements, any of these measurements could be the length, the width, or the height. So I'm just going to label as this just so we have some consistency. So we have 19 times 13 plus 4 times 19 plus 4 times 13. And then all of that, the sum of that is all going to be multiplied by 2. So 2 times 19 times 13 is 247, plus 4 times 19 is 76, plus 4 times 13 is 52. I'm going through it step by step. You may have done this in fewer steps, which is fine. I'm just showing you step by step, just in case you want to follow along or you want to make sure you're getting the correct answers. And in the end, we get 750 centimeters squared because we're dealing with area. Next is a triangular prism. So depending on how our triangle or our shape is given to us, and depending on what the formula sheet shape looks like, you may have to kind of imagine that you're rotating this figure. Maybe you're imagining that you're standing it up, so you're bringing this entire thing and standing it up. However you go about it, it will be easier to kind of compare the sides and figure out where the values are going in our formula. So the formula for the triangle-based prism is a little bit complicated. So the surface area is equal to B times L plus A times H plus B times H plus C times H. So based on the formula sheet, you'll be able to see where these values are going. I'll label it on our triangle so you kind of see where I'm placing these values. So A and C are the 2 values on our 2 diagonals on our triangles. The L value is the height of our triangle. The H value is the height of our prism. And the B value is the base of our triangle. So I'm just going to go through. We're just going to have we have 4 different faces. We're multiplying, well, a few more than 4. We have 5, but because when we have 2 triangles, we don't divide by 2 anymore. So base times length, so 12 times 8 plus 10 times 19 plus 12 times 19 plus 10 times 19. So going through and simplifying each one. Again, you could probably just do that all in one step and then add them up. I'm showing step by step just so that if you made a mistake, you can work back through it. So 704 inches squared. For our square base pyramid, now this is a square base pyramid because we're not given any of the side measurements, so we can assume that it is the same, or that they're the same. So we go to our formula sheet. Again, the surface area is equal to b squared plus 2bs. B squared would be the base, or b would be the base of our triangle. S would be the height of our triangle, not to be confused with the height of the pyramid. Right? So just keep that in mind. This S is referring to the height of the side or of the triangle, not the pyramid. So 11 squared plus 2 times 11 times 16, 121 plus 352. We get 473 millimeters squared for the surface area of our square-based pyramid. Finally, our last one, our cone. Again, our surface area formula, go to our formula sheet, pi r squared plus pi rs. So pi r squared for the base, and then pi rs for the lateral surface. So in this case, pi, or 3.14, times the radius squared. It's giving us the radius already, so that's nice. We don't have to do any extra calculations. Plus then pi times 19 times 16. The first one, 803.84, plus pi times 19 times 16, 954.56, and we just add those values together. 1,758.4 inches squared. So again, in this case, formula, or for volume and surface area of 3D objects, we're basically just using the formula from the formula sheet. We just want to make sure that we're comfortable taking the values and plugging them into our formula, because in some cases it can be tricky. You might have to reorientate, or imagine you're rotating the object you have to kind of match the object on your formula sheet, so you can pair up the values or fill in the values correctly. Again, just say the only other thing when dealing with units, remember surface area, the units are squared, and with volume, the units are cubed.